All right, hey guys, Mr. Fortin here. It is Friday. We just got done reviewing our section 3.7 problem set number 2, or second problem set for that. Of course, we had Tuesday. If you were in my 7th block, that was an extra credit assignment, although I highly recommend you had watched the video lessons. So get used to me as a teacher and get used to just writing proofs and getting practice with one another, okay? So I'm filming this video because I have that new class, right? I want to get you guys caught up. But because I think some of you guys, it clicked, right? You got the proofs, you got it done, you kind of understand how things connect. And then other people, and I was definitely in this boat in high school, other people in potentially might not see how it connects yet, but want to get it to connect. And you really want to put in that work and you really want to make sure you get it as best as you can. So if you see these people getting it, you want to get it too, this video is for you. Okay, so I'm going to go over section 3.7, then we're going to do 3 proofs right afterwards. Proof for number 9, proof for number 12, proof for number 18. Hopefully you can follow my logic. I would write it out. The only way to get better at doing proofs is just doing a lot of them. And if you can follow along with the logic, great, write it out. Then maybe try it again by yourself. Try it again. If you don't get it, throw it away, right? Then retry it again. Watch my video again. Try to do it again, okay? So we'll do this together. All right, so just real quick here, we had basic idea of section 3.7. So this is what you should have come away with. Like, I can't break it down like this any smaller than this, or I wouldn't present it to you like this just right away because you really just need to do the proofs to see how these worked out here. But the basic idea of section 3.7, which was called using more than one pair of congruent triangles, well, hey, we're going to prove two pairs of triangles congruent. In some problems, like number 16, you had to prove, well, 2 pairs of triangles congruent as well, I guess, in that one. But anyways, we're going to prove 1 pair of triangles congruent, and then that's going to be a helper triangle. It's going to help us prove a second pair of triangles are congruent. And that second pair of triangles being congruent, that's going to connect to what it is you're ultimately trying to prove. Be it specific segments in the problems, be it specific angles that you got to prove congruent, be it the fact that maybe 2 lines are parallel to one another. I don't know, whatever. We just need to solve our puzzles and get through it. So here's the structure. Just to remind you, this is the structure of all problems in section 3.7. So keep this in mind because you might have to do this again, right? You might not need to prove just 1 pair of triangles congruent, but get that second pair of triangles congruent, and here's how you do this, okay? So when I sit down to do these problems, and I'm going to do it just like the way that I do it, when I do it with you as an example in a second, problems 9, 12, and 20, the first thing I do when I set down in the proof, okay, step 1, okay, when you step down a proof like this, copy down diagrams, write the given premise, write the proofs, but look at it, mark up that diagram, and figure out, is there a way that I can find 1 pair of triangles that are congruent? And then immediately, if I can prove 2 triangles congruent, I normally do that right away, right? Do that right away, okay? Because if I can then prove, step 2, well, I find it, right? I find it in my diagram. Okay, I see I have a pair of sides that are congruent here, another pair of sides. I got this angle that's congruent to that angle, so maybe this is a SAS. I get triangles congruent because then that triangle can be, again, a helper triangle. Okay, so this is our helper triangle because if we can get 1 triangle congruent to another triangle, we can prove it. Then we're going to know that all 3 of the sides on 1 triangle would have to be congruent to all 3 of the sides on another triangle because corresponding parts of congruent triangles are congruent to one another. And corresponding parts mean the sides of the triangles and the angles of the triangles, okay? So step 1, find a pair of triangles that you think you prove it that can be congruent. Step 2, prove that the freaking triangles are congruent. Get it good to go, okay? Step 3 is a little vague. I put down this thing, this mysterious 5 letters, C, P, C, T, C, because that's what you do immediately. As soon as you get that first pair of triangles congruent in a section, or as soon as you prove congruent triangles, you got to ask yourself, why was I proving them congruent? Well, it's because I want to show a particular pair of sides are congruent or a particular pair of angles are congruent, okay? So you use your helper triangle to get you. Do you need to find a pair of sides that are congruent? Do you need to find a pair of angles that are congruent because they're corresponding parts of congruent triangles? I don't know. You will navigate that when you do the problems themselves too, okay? So the reason you're using CPCTC, you might just write CPCTC down in your reasons and then figure out what statement you need to say with CPCTC because this should connect to, right? Maybe I'll call this the prover triangle. because then you're going to find your helper. So these are your helper triangles. Okay, helper triangles are the ones you prove are congruent first. And then you have your prover triangles that you're going to prove congruent second. That's going to eventually get you to what you're trying to prove. So anyways, CP-CTC will get you a pair of segments are congruent. And then those segments might be in a different pair of triangles, okay? A different pair of triangles. So now once you prove one pair of triangles are congruent and you know all their corresponding parts are congruent, you're going to have more congruent segments to work with, more congruent angles to work with to then show a different pair of triangles are congruent. And that's going to be important because maybe that new prover triangles that we've proven are congruent now because we used CP-CTC earlier because we proved those original triangles are congruent. Now that we have the prover triangles congruent because we had all this information here, we can use CP-CTC again to get us to what we are trying to prove, okay? So step 3 was CP-CTC for the first triangle. Step 4, we're going to use that new part that we got was congruent to one another. We're going to use that to see if we can make a case, our argument that another pair of triangles need to be congruent in step 4. And then step 5 is oftentimes the last part of the proof. Step 5. And that's using CP-CTC again to prove what you were asked to prove. Okay, because ultimately this is a problem, you need to solve it. Solve it here. Okay, so problem number 9, for instance, we got to find this. We got to find that segment SK is congruent to segment YL. Do we know it's congruent? No, it says prove. We got to prove that here, okay? So what I'm going to do in this video is I'm going to follow those 5 steps here. And again, just get practice with me. Do these out and try to get used to the logic. We're going to keep moving through the curriculum. Hopefully you can pick up the logic as we go because this is Geometry B. We need to move on to Geometry B like topics here, okay? All right, first step. What do I got to do? I got to find one pair of triangles that are really easy to prove are congruent. I'm going to follow my reasons, follow my list of suggestions for you to do this yourself if you want to be somebody who knows how to do this rather than somebody who's, looking at it and not quite getting there. My first step is prove a pair of triangles congruent, okay? So step 1, find one pair of triangles congruent, and then, I can easily prove that. Look, we're given our helper triangle, okay? So here's our helper triangles right here. This is going to be step 1. And I'm going to talk about that first because do we have to prove those triangles are congruent? No, we don't. They're given to us that are congruent, okay? So I'll get my statements. I'll get my reasons set up. So here I have statements, and here I have reasons. So by a chain of reasoning, given these as premises, this larger triangle here, RST, congruent to this larger triangle right here, XYZ, that's going to be a helper triangle to us eventually proving that these things in blue are congruent, right? That's this here, SK. Segment SK is congruent to segment YL. Do we know that through CP-CTC yet? No, YL and SK are not corresponding parts of the 2 triangles that we know are congruent, the 2 black triangles right there, because corresponding parts means angles and sides. So angle T and angle Z, those are corresponding parts, for instance, and perhaps you're talking about that, okay? So statement number 1 is going to definitely involve saying triangle RST is congruent to triangle XYZ. That's a given premise, and we're going to use CP-CTC on that later. So we also have this to work with, or maybe I'll mark up the other stuff and include all my givens here, okay? So another piece of information that I have here is that we got a couple of bisectors. So we know that SK, ray SK, bisects is the angle bisector of angle RST. So we know that that's going to be congruent to that. Those 2 angles are congruent to one another. So we know that. Bisects here, okay? Then we're going to know this. We're going to know that ray YL bisects angle XYZ. Here's angle XYZ, so we're going to know that that is congruent to that, okay? So we know that's congruent to that. So then we have that. So now we're kind of thinking, how can I prove this? How can I prove that SK and YL are congruent to one another? So I started with these 2 triangles. I have these angles, right? So we're given information about angles. Okay, we're given information about angles. So my guess is here, we're going to prove another triangle congruent by using SAS, ASA, SAA, something that has an A in it because we're given some congruent angles. We just need to work to kind of get there, to solve this puzzle, okay? So step 1, get the triangles congruent. And then you start thinking about this, right? Prove that they're congruent. So step 1 and step 2 are taken care of for you. Step 3, CPCTC. How is CPCTC going to help us, finding a pair of sides, a pair of angles, what things we know are congruent, how's that going to help us get our prover triangles proving congruent? So let's check it out here, because there's a variety of ways we can do this. So basically, if we look at this here, I think the thing that we need to say is this through CPCTC. We need to say that angle RST has got to be congruent to angle XYZ, and that is through CPCTC, because look, angle S here and angle Y here are corresponding parts of congruent triangles. RST, XYZ, those are one of the 3 angles, and they correspond to one another of the 2 congruent triangles. So corresponding parts of congruent triangles are congruent to one another. And that's going to be helpful, because maybe, right, what we need to do in this problem here is to find that angle, right, angle KST has to be the same as angle LYZ. And if we know that what I said through CPCTC was that large angle there is the same as that large angle there, here we have kind of these small congruent parts here. Part plus part equals whole. These holes, the whole angle here, XYZ and RST, are the same measurements, and they're made up of 2 congruent angles. So what can we say about all these angles? They're all going to measure the same thing. So this is kind of a messy proof here, but if we can say KST is congruent to LYZ, then I'd have an angle, and you know what? Right, through CPCTC, I could potentially say ST is congruent to YZ, and angle Z is congruent to angle T. That's from my original triangles, those triangles right there, okay? Angle T and angle Z correspond to one another. Look at that, and the congruent triangles given to us. These are congruent, okay? ST and YZ, those correspond to one another. Look at that, ST and YZ. So here we have AS, and here we have AS. So the reason for this proof, or like we want to get maybe these lower triangles now, we're finding another pair of triangles we prove congruent. Get these lower triangles congruent because we can prove it by SAS or by ASA. And since we are given information about these angles right here, by these bisectors, we're going to work towards getting ASA being our reasons for getting these 2 things proven as one another here. Okay, so CPCTC, we would say that. I would also say ST equals YZ, and I would also say that angle T is congruent to angle Z, because that's sort of the fourth thing I'm thinking about. I'm proving another pair of triangles congruent. I'm going to say CPCTC because these 2 being congruent, that's going to help me get this lower below the blue, right? This triangle KST congruent to triangle LYZ. That's an angle in the small triangle, but it's also an angle in the big triangles that we know are congruent to one another. So that's congruent to that. And then this is a side in the smaller triangle here, but YZ and ST also in those congruent triangles. That's why it's CPCTC from step 1, okay? Step 3 is we got to somehow prove that KST and LYZ are congruent to one another. And there are a variety of ways to do this. I think in block 5, somebody did a cool way of doing it. I suggested maybe an easier way of doing it. And this is how I would do this here, is that I would actually use the angle bisector theorem and say that 2 times by measure of angle KST would have to equal the measure of angle RST. And that is the angle bisector theorem from chapter 1. Okay? And then I would also say 2 times by measure of angle LYZ, right? LYZ equals the measure of angle XYZ. And that's also the angle bisector theorem, so that's still part of step 3. And that helps because, here, I need to move this out of the way. And I'm doing that because what did I know from step 2 as I'm sort of working with this puzzle here? I know that step 2, that measure of angle RST, let me change this to an equation here, that RST and XYZ, they both measure the same thing. Like, they both measure the same thing. Remember, that was from CPCTC. So we got to chain of reasoning, connect this stuff together, okay? RST, XYZ through CPCTC, they equal the same thing. So 1/2 of this equaling that, and 1/2 of this equaling that, twice this angle equaling that, and twice this angle equaling that, we can now say, right, because we can take this, we can replace this statement here, RST equals 2 times measure of angle KST. I can put that in the left side of that equation in step 2. I can put 2 times by measure of angle KST, and then that equals 2 times by measure of angle LYZ. Okay? Why can I do that? That's called the substitution property of equality. Okay? Because this here, we see the same things. This here, our measure of angle RST equals measure of angle XYZ. We got that from CPCTC a couple steps ago. And so what can we do when 2 times measure of angle KST, that equals this? We can replace this. We can take this and put it in right there, which I did down here. We can take this, we can take this, which equals measure of angle XYZ, and we can replace this up here, which is what I did right here. And that's important for us in this proof because we're trying to prove this bottom triangle and this bottom triangle are congruent by ASA. ASA. That's how this one works. Okay? So then we get step 5. I want to say that not just twice the angles, 2 times that angle equals 2 times that angle. I want to say just that one angle equals that other angle. And the way I can do this is by division. Division property of equality. Doing one thing to one side of the equation as you do to the other, that's called the division property of equality, which was in section 1.4. Okay, so we have here measure of angle KST equals measure of angle LYZ, and that's through the division POE, or division property of equality. Okay, and now we've said it. Now we've said enough information here to get these two things congruent by, look, here was a side, right? ST congruent to YZ. Here was an angle. Okay, angle T congruent to angle Z. There's an angle. And then finally, we did all this garbage, all this work right here to prove that we have another angle. Okay, right here. This angle has to be the same as that angle. So they're all congruent to one another. They're each half of 2 congruent angles. They're going to have to be congruent to one another. Okay, so this is ASA. ASA. Look, the side is included between those 2 angles that we know are congruent to those the angles right there. The side's in between, right? Included by those angles. Okay, so this is going to be enough to prove that those 2 bottom triangles, triangle KST congruent to triangle LYZ by ASA. Okay, and then, right, so those are our prover triangles here. So we proved, so just to summarize, right, this was the whole point of this section, was find a pair of helper triangles, say that they're congruent, use CPCTC to get parts of another triangle that can help you, parts of other triangles, plural, that if you say they're congruent, then by CPCTC, again, double CPCTC, you'll prove what it is you were set out to prove here. Now, what we're set out to prove is this. We're set out to prove that SK and YL are congruent to one another, and we can do that as soon as we have this. Look, we have SK. KST, triangle KST. Let's see, what am I trying? Oh, yeah, SK. Yeah, SK is right here. So we have KS. Look, KS, this is SK. It's the same way we would write SK. Doesn't matter, right? If we're talking about segments, it doesn't matter what points we're talking about here. Distance KS is technically what that would mean, but segment KS is the same as segment SK, right? It doesn't matter the order of the points we use here. So we got SK right there, and we got YL. YL right here, or LY, okay? So these here, right, I proved that through ASA, that those bottom triangles are congruent to one another. So through CPCTC, SK is congruent to YL, or yeah, SK is congruent to YL, and that wraps up the proof. Okay, SK congruent to YL. Okay, so maybe rewatch that. Send me your questions. Like if you really want to get it, like I'm willing to help you out. I've stayed with a lot of people 7th block already, try and get you caught up, and then again, I will probably never. If you're in 7th block, you're probably not going to get perfect. I think it proofs this year, but you at least maybe figure out kind of what's going on. Proofs kind of go not a way, but like they're way less important in future chapters, maybe like starting in chapter like 6 or 7. So, all right. So anyways, there's that for that one here. Okay. So to reiterate, find a pair of triangles congruent, prove they're congruent. CPCTC helps you prove another pair of triangles congruent, and then use CPCTC again to state whatever it is you were trying to prove, which was this here, which we couldn't have gotten from the first triangles we got congruent. Okay. So that's why I call this section double CPCTC. All right, that's that. Stay tuned for my next video. I'm going to do number 12, and then I'll have another video doing number 20. Thanks for watching, guys. Bye.